For today's demonstrative speech, we'll be going over the process of designing and building your own pair of snow skis. Now, this I did in my last semester of high school, and I've compiled footage of the experience, and today we'll be learning how I did that. The first step in building a pair of skis was to learn how, because I had no prior experience, and the best source I found was skibuilders.com. Skibuilders.com provided a plethora of information about the design process, the materials used, and the pressing process of building a ski. Here we look at the materials required for building a ski. The base of your ski is going to be your wooden core. For my ski, we used an ash and poplar laminate. We then have the base material, the edges, the sidewall, which in my ski we did not use as we did a capped construction, the top sheet, and the composites. For our ski, we did 2 layers of fiberglass and 1 layer of carbon fiber. All materials for this project were sourced from the skilab.com. Skilab.com is an online store that gives you access to all the materials needed to build your own pair of skis or your own snowboard. That is with the exception of epoxy, which was cheaper to source from locally. The first material was the base material. This is a 4001 grade PTEX, and there was 2 meters of this required. We then have our metal edges, which are 80-inch long sections that go on the outside edge of your base and allow you to cut through the ice better. We then have our edge tape. It's made out of a VDS rubber, and it is laid along the metal edges to help reduce vibrations and prevent delamination. We then have our triaxial fiberglass. We used a 22-ounce triaxial weave, which means there's a 3-direction weave. We then have our tip and tail material, which, as the name implies, goes in the tips and tails and helps hold its shape during the pressing process. It is a cardboard composite material. We then finally have our top sheet material, which is the last piece of the pressing process and gives a smooth and refined finish to the top layer of the ski. This came to a grand total of just over $112, and that does exclude shipping and tax costs. Now here, as we begin the pressing process, you can see myself and my friend in the red hat, Michael, begin to mix the epoxy. It's extremely important that the epoxy is mixed properly, as the hardener and the resin need to be completely combined to have a perfect curing process. We have now begun painting the epoxy onto the base of the ski. It's important to get full coverage of the base of the ski so that there is no air spots or anywhere with a lack of coverage. Now here's where we are applying the VDS rubber that I mentioned earlier and applying more epoxy to the top of it. This rubber helps prevent delamination, which means the glue separating due to vibration within the ski, and can help increase the longevity of your skis. We are now applying the first layer of the 22-ounce triaxial fiberglass. Once the epoxy or the fiberglass is in its proper place, we begin painting the epoxy through before adding any more to the top. It's important to get the epoxy below to soak up through the fiberglass, and then if necessary you can add more on top to fully saturate it in epoxy. You don't want any dry spots again, so that there's no areas that are not being glued. We have now added the wood core that we have applied epoxy to the bottom and are applying more to the top. This once again is an ash and poplar laminate that we built in the shop. We are now applying the second layer of the 22-ounce triaxial fiberglass and once again painting the epoxy through so that we are getting a good bond, and then adding any remaining fiberglass to the top. Here we are adding the carbon fiber layer. We did 2 strips of carbon fiber on each ski, and this helps increase the stiffness of the ski to get the desired effect for the type of skiing we want to be doing, which for this specific ski is a powder-oriented ski, so the deeper snow, so we had a wider, stiffer ski. Now I'm adding the final layer of fiberglass, which is going to be a small section that goes in the base plate area. This is so that the mounting screws for your bindings have an extra bit of fiberglass to screw into, so you have less risk of ripping out the screws for your bindings. We've just added the top sheet material, which has a cloudy appearance initially, but as it has pressure on it, it has a clear appearance. Now, the actual press itself uses a vacuum, and here we are taking our vacuum bag and sealing it to the table so that we can turn on the vacuum pump. The vacuum pump runs at just around 20 to 25 psi, and the skis are in this press for 12 to 18 hours. The press is able to suck down your materials so everything is squished together really tightly and to the shape of the press, which we have pre-designed, as you can see on the table, using all the clamps. One important thing is that your materials might not be aligned properly. And here we can see us having to go in and shift things around a little bit that didn't quite line up properly. And that is something that's crucial so that we have a good layup and everything is lined properly once the epoxy is cured. Now that we've decided that everything is aligned to the way we want it, we begin checking for any leaks in the vacuum. We just ensure everything is functioning properly. Now you can see we are lifting the tips and tails to achieve the desired shape we want. This press also has the lines running along the edges of the ski that you can see, that is where it's pulling all the oxygen. We're also pushing excess epoxy into those lines because we don't want any thick spots in the ski, because it will cause a weak point. We're using the rollers that we could see, and now we're using ball bearings to help get all the oxygen out of the edge of the ski. Once we've pushed all the skis out, we turn on a fan to our pump so that we don't have any heating issues, and we continue to monitor for any leaks, because if we have a leak in air pressure, we're not going to get the desired amount of vacuum, and that will create a weakness in the press. One thing that I did that was a little unique was the crosses that you can see in the ski. I used a die cut machine, and I thought it was something that was you're never going to see on the slopes, and if you do, you're going to know that I made the skis, and I don't think anyone would ever question that. This project would not have been possible without the help of John Hadley of the Columbia River High School in White Salmon, Washington. He's the man that we can see in the top right of the screen. He was an amazing resource, and he had prior experience to building skis, and we had the opportunity to visit his shop, and we were able to press a set of our skis under his supervision, and using his knowledge we had amazing success, and we ended up building 6 pairs of skis, all of which turned out wonderful, and we're all super excited to hop on the snow and try them out. This experience was amazing, and we were able to learn about composites and material sciences and vacuums, and it was really an amazing learning experience, and something great came out of it, because now I have a pair of homemade skis that I can go ride on the snow. And it's truly been an amazing experience, and this can easily be applied to building snowboards or even wakeboards. And so it's been a great experience, and without the help of amazing people like John Hadley and the resources on places like skibuilders.com, and of course the support of our own woodshop teacher, Mr. Anderson, this project would not have been possible. And I'm very grateful for the experience, and I hope you guys learned something. Thank you very much.